All right, here we go. This is the homework for Monday, November 14th, Chapter 3, Lesson 6, Day 1, Real-World Problems Involving Decimals. And just as a reminder, if you want extra practice on this, you can check out textbook page 147 and 148. Question numbers 1 through 3 and 6 will be specifically related to this. So here we go. When solving these word problems, I do want you to make a quick model. Remember to make sure your answer is in a sentence, and please check for reasonability. So Leo rode his bicycle for 75 hundredths of a mile and then walked 215 thousandths of a mile to reach his school. He must have a really precise device to tell him those distances. How far did he travel altogether? So I'm going to start out with my sentence so I don't forget about this. Leo traveled blank, and I'm going to put my miles there so I know I have my unit already. Leo traveled blank miles to school. Now my quick bar, we know that he is taking a bike and he is walking. So he travels 75 hundredths of a mile. And a little bit smaller than that, he travels 215 thousandths of a mile. So because I want to know how far did he travel altogether, that to me sounds like addition because I'm combining those two values. So here is what I'm doing, and I didn't make a blue bar, but I can create one myself. So I know that if this was 75 hundredths plus 25 hundredths, it would be about 1 mile. So when I add these together, I should get something near there. So I'm going to set these up vertically, 75 hundredths, making sure I line up those place values using that decimal point. And I am going to highlight my sign because I definitely want to make sure I do the correct calculation here. So 75 hundredths is equal to 7,000 or 750 thousandths, and that gives me a digit in that place, in the thousands place. So now I can just add. 0 plus 5 is 5, 1 plus 5 is 6, 7 plus 2 is 9, and there we go. Definitely need that decimal point. So Leo traveled 965 thousandths of a mile to school, and that seems to check out with my estimation at the start. Moving on, number 2, the volume of water in a tank was 9 and 56 hundredths liters. Reese scooped out 693 liters of water from the tank. Very precise again. How many liters of water are left in the tank? So I'm going to start with my sentence. Again, there are blank liters of water left. And for this one, because we're starting with one amount of water and then taking away from it, I'm going to use one big bar to show the amount that we have. And then we know a portion is taken off, which has 963 liters as a value, and we want to know that amount there. So this to me, since we're starting with an amount and then taking away from it, sounds like subtraction. And I know that these numbers aren't super duper friendly, but if it was 9 and 693 thousandths, which is really close to 9 and 56 hundredths, and I subtracted that, I would get 9 liters. So I need an answer that's somewhere near there. So I'm going to calculate this vertically, being sure to line up my work there carefully. Again, I am going to highlight my sign. I just really don't want to make that silly mistake. And I do know that 56 hundredths is equivalent to 560 thousandths. Now I'm a fan of doing all of my regrouping first, just so I don't make a mistake there. I get in that mode and I'm ready to go. So starting with my thousandths place, if I'm starting with 0 and subtracting 3, I don't have enough. So I'm going to take one of those hundredths and turn it into thousandths. Now that leaves me with 5 hundredths, and I'm subtracting 9, so that's not going to work out. So I'll take one of my tenths and regroup that, which leaves me with 4, and I'm subtracting 6, so again, not good enough. So I've done my regrouping, now it's time to subtract. 10 minus 3 is 7, 15 minus 9 is 6, 14 minus 6 is 8, and I still have 8 in my ones place. So there are 8 and 867 thousandths of a liter of water left, which is relatively close to our estimation there. Now, a pound of beans costs $7.80. Those are some fancy beans. Mr. Plaska buys 6.5 pounds of beans. Who wrote this problem? That's a ridiculous number of beans. How much does he pay for the beans? So Mr. Plaska pays blank dollars for the beans. So if we know that here's 1 pound and that costs $7.80, we have that 6.5 times. And we want to know how much is that cost. Wrigley, please do not bark right now. So to me, that sounds like we are going to be doing $7.80, 6.5 times, or 6.5 groups of $7.80. So that's like multiplication. Now, reasonably, if this was $8 a pound, and I bought 7 pounds of them, that would be $56, which is a ton of money for beans. But I'm going to set this up and solve it vertically. $7.80. Actually, I'm going to get rid of those because I don't need that. Because 80 hundredths is equal to 8 tenths. Let's save ourselves some work there. Now, when I set this up vertically, I am going to... Wrigley, are you serious? Cut it out, bro. Got it set vertically. I need to identify and then ignore. So 1, 2. It's 2 places. I'm going to multiply. 8 times 5 is 40. 5 times 7 is 35. Plus 4 is 39. Now I am moving over to another place. So I'm going to put my placeholder there. 6 times 8 is 48. And 6 times 7 is 42. Plus 4 is 46. I'm going to add these up. 0, 7. That's a 10. So I'm left with 5070. So now I need to move. And because I've done my estimation, I know my answer should be somewhere near 56. So I definitely wouldn't have an answer of 570 because that's so far away. $5.07? Well, that wouldn't make sense because that's not even the cost of 1 pound of beans. So I am certain that if I move it 1, 2, just 2 because that's the number of swoops, that the answer of $50.70 would be reasonable. 5070. Again, apologies for the dog barking. He's lost his mind. So we set it up vertically. We identified and ignored. We multiplied. We moved. And we got our answer. That is reasonable. Awesome.